This question came for 2 marks in 2018 for EC GATE. Let's see the question. The circuit shown in the figure is used to provide regulated voltage 5 volts across the 1 kilo ohm resistor. Here the load resistor is fixed, which is 1 kilo ohms, and even the output voltage is fixed, which is regulated voltage, which is 5 volts, which is in fact the Zener voltage of the Zener diode. Assume that the Zener diode has a constant reverse breakdown voltage for a current range starting from a minimum required Zener current Iz min is equal to 2 milliamperes to its maximum allowable current. So the maximum allowable current value is not given here. So if you take the Zener characteristics, only the minimum current is given, that is 2 milliamperes, and the breakdown voltage is also given, which is 5 volts. Now the input voltage Vi may vary by 5% from its nominal value of 6 volts. So input voltage is given 6 volts, but as mentioned, it may vary by 5%, which means it can go up to 6.3 volts or it can go down as much as 5.7 volts, which is 5% above or 5% below. The resistance of the diode in the breakdown region is negligible. In fact, the curve we have drawn here is pretty straight or vertical line here in the breakdown region, assuming that the resistance of the diode is negligible. The value of R and the minimum required power dissipation rating of the diode respectively are. Now we need to find what is R value and the power rating of the Zener diode. Now as they have mentioned that the output voltage is regulated and it is at 5 volts, which means the amount of current that is flowing through the load resistor will be 5 volts divided by 1 kilo ohms, which will be 5 milliamperes. So let's make that here 5 milliamperes. Now as the load is fixed and the voltage across the Zener diode is fixed, this value is going to be a fixed value. Now the amount of current that flows through the Zener diode will be starting from 2 milliamperes, which is the Iz min, which is the knee current. Now this current minimum that can flow is this knee current, and it can flow higher than this depending on how the voltage is changing at the input. Now this current should be accounted for the lowest input that we are applying here, and that voltage is 5.7 volts because the voltage at the input is changing from 5.7 to 6.3. So for the minimum voltage we have to see that the Zener diode is still in breakdown region, which means it should be accommodating the least amount of current possible, which is the knee current, to keep it in breakdown region. So assuming that, now at the input we have, let me draw the circuit. Input voltage is 5.7 volts. Now the amount of current that is flowing through R should be equal to, the current should be equal to 5.7 volts minus 5 volts, 5 volts at this node, divided by R, and this current should be equal to, as we just discussed, for the minimum input voltage, the Zener diode to be in breakdown region, it should be taking 2 milliamperes, which means the entire amount of current flowing through the current limiting resistor will be 7 milliamperes. This can be written as 5.7 minus 5 is 0.7 divided by R is equal to 7 milliamperes. With this we can find the R value, which is equal to 0.7 divided by 7 milliamperes will be equal to 100 ohms. And the next one is the minimum required power dissipation rating of the diode. Now we have a Zener diode here, but in this case the load resistor is not variable, it is a fixed quantity. So hence the maximum amount of current that can flow through the Zener diode, keeping the variation of the input voltage, is the input voltage maximum will be 6.3 volts. When input is 6.3 volts, the current will be equal to 6.3 minus 5 divided by R. Now we know what is R, which is 100 ohms. So 1.3 divided by 100 ohms, this is volts, is equal to 13 milliamperes. Now we know 13 milliamperes is flowing through the resistor R here, out of which, as the load is fixed and the voltage across the load is 5 volts, as the Zener diode will be in the breakdown region, the current flowing through the load resistor will be 5 milliamperes. So 5 milliamperes will be flowing through RL out of 13 milliamperes. So how much would be flowing through the Zener diode? It will be 8 milliamperes through Zener diode. The voltage across the Zener diode is 5 volts. So the power rating is equal to 5 volts times 8 milliamperes, which is 40 milliwatts. So the resistance is 100 ohms and the power rating of the Zener diode will be 40 milliwatts. So the option is option B, which is correct. The most important point about the minimum required power dissipation rating is, if we want to choose a diode, we have to choose a diode whose power rating is at least a minimum of 40 milliwatt in this given circuit where the load is fixed. Of course, we can pick a Zener diode whose power rating is higher than 40 milliwatt, but we are asked what is the minimum value. We need at least 40 milliwatt.